presentation, there's three of us. My name is Ingvar Bjarnason. I'm the IT director of CCP, also known as CCP Red Button. And this is Andrés Sighvatsson, also known as CCP Major Gormur. He is the lead system admin for the Virtual Worlds team that manages the hosting operations of EVE Online. A little bit of trivia for those of you who are interested in that sort of thing. Major Gormur is the oldest character in EVE. So you got a celebrity in the house.
Number one. Numero uno.
He was the first character to actually grace New Eden with his presence. And then we've got James Wild, and he is the infrastructure lead for Dust 514. EVE's original design. The initial design criteria for EVE back in 2003, it was designed for a user base of 120,000 people. Peak concurrent user count, PCU, was up to 20,000, 20% of that total. It was one shard all the way from the beginning. And we estimated an average traffic per client of 6 to 8 kilobits per second. And that's actually remained quite constant throughout the years, although we're up to, I think, maybe around 20 to 25 kilobits per second now. The reason why it was so low is because back in the day, people had to play on modems and such, and you had to accommodate for that. No broadband. At least it wasn't as common as it is now.
There's an interesting piece of trivia, actually. When I first signed up to EVE, back in 2003, I actually had to download the entire client, about 600 or 700 megs over a dial-up connection. Took the entire weekend.
EVE was from the beginning a layered design. Load balancer, proxy layer, application layer, and a DB layer. And the plain vanilla database, without any user data in it, was 3 gig in the beginning. My, how things have changed. On average, we estimated 1 megabyte of data per user. It was actually substantially less, as it turned out, and still is. Today, we have, on average, about 300 kilobits per user in the database. But that varies a lot, depending on how active that particular user is. We had some ideas for growth back then. We were actually contemplating more shards with a limit of 120,000 users per shard, and the possibility of resource pooling between them. Obviously, that all changed, and luckily, because I couldn't imagine EVE right now on multiple shards. That just wouldn't be the same. EVE's original design was a simple layered network design with a whole lot of switches and a whole lot of Ethernet cables to plug back and forth. That is the original diagram. And in many ways, we've remained true to the concept, but it's radically different right now in terms of the actual equipment and the actual physical layout. These were 20 Sol servers, 14 proxy servers, dual Xeon, 2.8 gigahertz with 2 gigs of RAM. These were state-of-the-art beasts back in the day. Probably qualify as a low-end refurbished desktop now.
These were the Pentium 4s, the Prescott series, which were running, I think, around 95 degrees centigrade. And in the data center, at peak hour, the back of the cabinets, which were closed in a closed cabinets, you could not put your hand on the back of that cabinet and keep it there. You could almost boil or fry an egg on that. It was so hot. It was just immense heat coming out of those servers back then.
In total, these were 190 gigahertz of processing cycles, or processing power, and 68 gigs of RAM. That was the entire cluster back then. And for some amazing reason, I don't know why, the storage, the raw storage on TQ was exactly 666 gigabytes. Go figure. An omen or what? Today's design is the same logical design, but it's quite considerably beefier. We've got 220 Soul server cores. We've got 48 proxy server cores. These are varying degrees of hardware depending on the application, ranging from Wolftails, 3.3 gigahertz, to an Everest node running at 4.4 gigahertz, and that's actually our Fleet Fight node. That's what you play on when you want to have epic, massive battles. All in all, this is 1 terahertz of processing power and 4 terabytes of RAM. 4 terabytes of SSD storage, and this is mainly for the database, because the database runs entirely on SSDs, and then 20 terabytes of fiber channel or SAS storage for both TQ and all of the additional components and services. Over the years, we've continuously added more components to Eve. More features, more services, and these are just some of the more prominent ones. Now we have the API, which we didn't have in the beginning. We have the image server, which serves basically all of the character portraits and other things in-game. We've got EveGate, and we have the forums. We did have the forums back in the day, though. And then, of course, Eve. And it all ties back together into the underlying database infrastructure. In addition to all of this up there, there's a multitude of unseen components. We have storage networks, network equipment, routers, switches, firewalls, IDSs, etc., etc., etc. And we have a whole lot more complexity today than we had back in the day. Back in the day, it took an admin team of 2 to run TQ. Now we are 11. We're quite busy, I think it's fair to say.
I'm going to go briefly over the history of the servers that we have been running on Tranquility. 9 years running Eve, having hamsters, wheeling those servers at maximum capacity. You people always tend to group together in the same system, if it's Jita or other 0-0 systems, to fight all together, which is a pain in the neck. Gives us a really, really hard time. You are forgiven. We try to make it up, of course, giving you larger hardware and more power, and then getting our programmers to do some optimizations, as you've read in a lot of dev blogs, optimizing our code and so on, and then also adding on more hardware. The servers that we've been running, these are the servers that we've run through the past. These are all IBM series, the X series, starting with the 335s, which Ingvar was mentioning, the 20 servers at the start. In the first year, we grew them by half, going from 20 to around 50 servers. Then, soon after that, we started growing on the proxy layer. We needed more power. Then we were introduced to the blade centers. We got the HS20s, which were blade center models. We got 14 of them, more powerful processors. And soon after that, we were up to capacity again and needed to upgrade everything again. And we switched then over to the AMD processor. Throughout the history, we've always done comparison on AMD and Intel. And this is back in 2006, where just AMD was a superior processor. So we went to them. This is the Opteron 2.8 gigahertz processor. And every almost one and a half years, we've done these upgrades. Then we went to the HS21s, the XM series, which we are currently running 3.3 gigahertz for the total of the cluster, except for those super nodes that we have running. The super secret node, which is not a secret anymore, but when we were running it for the past few years, you couldn't find anything about this node, and but it will be revealed more later on. Here is a server upgrade, which we got. These were, I think, 120 servers that we installed completely. These are the AMD series. The last upgrade we did after that, we have the servers down again, going from 120 bare metal down to around 50. And if we would do this again, we are estimating that we could go down to around 25 with the current architecture that's going on. Here we are decommissioning old hardware. These are all blades that all this stack has been now put on 4 machines. So these are management services that we have, all the test servers, in-house test servers, and the bug hunters test servers. They've been all virtualized now, and this is basically probably 10-15 kilowatts of power that we're just taking out there and throwing away, and now running on only 4 servers.
We've gotten good mileage out of these servers because they used to run TQ back in the day, and now they've been relegated slowly and slowly. And our office IT guys, they often complain that they get all the hand-me-down stuff from TQ.
Yeah,
so we try to make the best use of the hardware that we have.
Are these the same blades that were in the picture just before?
Yes, these are the same picture, just a couple of years later. But a funny fact that the first ever servers running the 335s and 345s, they are actually still in production, not in production, they are still in use. We are just now decommissioning them. We have, I think, 4 servers left, and then that's since 2003, and still happy, live kicking, whatever they're doing, but nothing in production for you guys, so no worries there. Our database servers have also gone through a series of updates. Every 1.5 years or so we have done major upgrades. The first ever server, 445, 4 gigabytes of RAM, 2 gigahertz, single core. Not very powerful for today, but 2005 we upgraded, going up the gigabytes in memory quite considerably, and the dual core technology kicking in then, and we are getting more power out of the servers. 2007 we do it again, but we then increased the memory a lot, which gave us really good performance, and like we've seen, we've grown. Like 2009 we go again up to 128 gigs of RAM, and then 2011 with the latest upgrade of the database we went to 512, and that's where we are up to 8 cores with hyper-threading. So it's basically looking like this. 32 cores running now with the latest upgrade, the CPU before and CPU after. So we were running around 50% CPU, peaking at 80% at peak hours, and after this new upgrade with a large memory and also going with the new the IBM StoreWise V7000 on SSDs, this dropped considerably down, and the CPU has really dropped, and we are really good on DB power now.
There's actually something interesting in that graph, if you just want to bring it up again. The spikes that you can see there relate to when we perform backups of the database.
Yeah.
And it's very interesting as we've upgraded the database server over the years, how our backup time has gotten progressively shorter and shorter and shorter. And what you can see there actually is that from the previous database server, we've actually taken backups down by 1/3 in the amount of time and resource they take, which means in the event of having to move databases around for singularity, for shifting large amounts of data, it gets so much quicker and so much more efficient. with these newer generations of hardware.
Yeah, and we take a backup every day, full backup, and we restore it on a research and statistics database, which our Dr. Ayo has access to. So he has always fresh data from Tranquility every day to research what's happening. So he gets a snapshot of our database, which is one of those bumps, and it's restored on his database where he can go in and mine data and do graphs and reports for you and the executives. The Eve ecosystem, Eve was pretty simple in the beginning. We had Tranquility, we had test servers, and we had web servers. And that was more like Eve Online and forums and CCP games. There was nothing else. Then we added on new forums, which were pretty much more complicated to run than the old forums since they were bundled into Tranquility. Now these are separate forums which we took out. We have added on the API as well. That has caused a lot of headaches for us in the running years, performance issues and so on that we've countered, and we've had to tackle it on many fronts, adding a caching layer and putting prevention mechanisms for people DDoSing us. So this is one of the most systems that gets those kind of denial of service attacks because of all the bad programming from the third-party vendors. We have the eVoice integrated now, came in. It's a third-party vendor that runs it, so it's not up to us to running it, but of course we have to be on top of things, what's happening on their side, and we're in communication with them when everything goes. Reports, that's the research and statistics database that came on. Added this extra layer where we had to have that always up to speed. Then Eve Gate came along, another fairly complex system, which James initially set up and designed, and was a really great launch, but was just missing the functionalities in order to kick it off at the heights that we were wanting it to go. The test servers, we have a whole lot of test servers. I couldn't even count them. There are so many. We are always going in that direction of performing better performance for our QA guys to get their testers up to speed. So we were building a lot of tools for them to then now control them, because we used to always have to do everything. So we are now developing a really good system where they can just spawn out their own test systems on the fly with the latest, greatest additions, or fall back to some later graphs, later builds. Deployment, we've been doing a lot of things with our internal tools in deploying TQ. The downtime of TQ has been our main concern for the last probably 2 years now, and we've been really battling getting it to a minimum. And with the deployment tools that we have and the updates that we need to do, we've been battling getting those very fine polished to get the minimum downtime needed every day and during major deployments.
You probably may have noticed that the downtime has been shrinking continually. So now, even though we advertise half-hour downtimes generally, unless there's some work being performed, last about 5 to 6 minutes, which is actually pretty damn sweet.
It's a lot better than an hour.
Mm-hmm.
Yeah.
I used to have to play from Australia.
That
would hit right at 7 p.m.
And then the SSO, which is the single sign-on, which you've been hearing about, that's coming into the mix. Will be coming on live sometime this year. And you will see more complex features on that later on. But Ingvar, you're going to take some more details.
So how's everybody doing so far?
Who was on pub crawl?
Who's hungover?
We specifically designed the first part of the presentation with a lot of stats and CPU numbers and stuff like that to give everybody a splitting headache. We succeeded. And there's more to come. Here are some of the major milestones of 2011. We've, as we explained before, we've been undertaking a major virtualization effort. We didn't do a lot of virtualization before. mainly because we had a lot of hardware available from previous iterations of hardware on TQ. So there was kind of no real incentive. But in order to improve our flexibility and our speed of deployment, and also just to be able to save on power and space, we transformed basically during 2011 most of the infrastructure in London, although we haven't touched TQ so far. There are some thoughts about virtualization on TQ. There are different schools of thought in that area. The benefit would be, because on TQ, during the average run, about 80% of the nodes are running at less than 20% average load. That varies, of course, from service to service within TQ, whether it's Empire Space or Nullsec Space or wormholes or whatever. But the large majority of the nodes are not utilizing their full CPU potential. Virtualization could address that by stacking virtual servers together and thus getting better utilization out of the hardware. But there is another way to tackle that as well, and that's actually in code, which is arguably a better way of handling it. If it were addressed in code, it would be by enabling us to move services within Eve smoothly from one set of hardware to another. Thereby, we could easily, without disconnecting sessions, thereby we could easily isolate fleet fights that happen impromptu on hardware nodes that share other services. And this would actually be a pretty sweet thing. And I know for a fact that there's some initial development efforts going on in that direction. And that would be killer. And ultimately, we could even combine the both. But this is still being debated. But the infrastructure is there. We have the virtualization clusters in place, and we have all the components, all the building blocks that we need to do this. We did a major DB upgrade in 2011, like we've discussed before. The reason for that is we're preparing for growth, of course. We have today, this year, we have Dust 514 coming on, and all of that ties into the same main DB. So, of course, that needs to be scalable and capable of handling all of that additional load. But then again, also, we were addressing issues of disaster recovery and failover capabilities and high availability. We needed to beef up in terms of high availability to make sure that any issues we had on the DB didn't impact the running services. We've been doing a lot of storage consolidation during 2011. So basically, 2011 has been a year of transformation in our IT infrastructure. We've consolidated what was prior a very disparate set of storage area networks and storage arrays into one big storage area network and storage infrastructure in London. And this enables us to be faster at provisioning services and to be more flexible in whatever we want to do. If we want to add storage or if there are some emergencies or issues coming up, we have the flexibility there to respond to that. We overhauled our internet peering. We are peering with 6 major providers in London. We operate our own peering platform. And in addition to the peering platform, these are all Tier 1 ISPs. In addition to the peering platform, we're also utilizing a product called FCP. Some of you may have read the dev blog about it, but it's a device that sits on our peering fabric, and it continually monitors all connections into TQ. Every client connecting in, it monitors the path to that client, and it monitors it for latency and for packet loss. Basically quality of the connection. And if it finds that there's an alternate path available, it will modify the outgoing traffic to try to optimize the traffic. So we're trying to improve the quality on each and every user session on TQ. And actually, by introducing this platform, we've seen substantial improvements in performance for traffic and sessions on TQ.
Yeah, also on that note, prior to getting this box, we also had to do this manually. We had issues and complaints on either through customer support or the forums, and then we need to go track down the users for more information, what ISP they were coming from, what was their connection, and then trying to debug if it was just their local computer, and which took a considerably much longer time and effort on our part and your part and then customer support. But with introducing this device, it literally just does this automatically. So the user experience is much better, although there are cases where people will still have of course problems because the internet is a big bubble that we can't control.
Yeah, and mind you, we can only control the path to the user. We cannot control the path back to us. And this also has helped us a lot. If there are some issues on the internet, black holing of traffic and such, that gets repaired automatically. Not immediately, but in a couple of minutes, if you have some issues with your ISP and there's an alternate path available, this will reroute and fix. We've done a lot of hardware upgrades on TQ. I have another slide on that topic. And we've added the fleet-wide supernode to our arsenal to combat the dreaded lag monster. We've overhauled the proxies on TQ. We've added new hardware, IBM HS22s. These are 3.6 GHz Westmere CPUs, 8 CPU cores per blade, and it was a substantial boost. If you observe the graph, the red graph is the scaling of the proxies prior, or actually on the old hardware, and the green graph is the scaling of the proxies after we added the new hardware. And the capacity per proxy, or per actually proxy node running, is substantially higher, even though the clock rate is not that higher. And this is just due to vastly improved architecture on this new motherboards and new design and architecture on the chipset. We're now up to 40,000 players per proxy, per physical proxy blade. So theoretically, we could run all of TQ on just 2 proxy blades. But of course we don't, because what happens if one of them fails? We've also added the fleet-wide supernode. And it's an IBM X3650 M3 running at 4.4 gigahertz. It's overclocked, and it's actually the best that money can buy in this area. It's mainly used by high-frequency traders on Wall Street, and then, of course, by you guys blowing each other to bits.
It's an interesting... Oh, go on.
I've actually met quite a few IBM engineers that were working on the Everest node. And when I mentioned that we have the Everest node running, and they were all quite surprised because they've only heard like Wall Street, military complexes, and those high, government agencies buying this. And when they heard a gaming company was using it, they just lost their faces and just, what are you using it for? We have users that need CPU. That's all.
It's pretty funny as well. When we installed it into our data center, it came with specific instructions that it had to be placed right on top of one of the air conditioning vents.
Yep.
Because for those of you that do a bit of overclocking, you probably know that once you get above 4 gigahertz, it starts to get pretty hot.
Yeah,
and this thing is actually air cooled as well, so there's no water cooling or anything like that on it. And so
the instructions were that it needed to be 10 degrees centigrade air going into the server to keep it alive. And Intel only guarantees you this CPU for 1 year because they know it's going to break.
And although some of the software guys may disagree, we'd like to claim a little bit of the fame for boosting fleet fights just due to this monster. But in order to get on this monster, to actually wage war, you have to notify us prior, because this is a dedicated fleet fight node. So if you send in a dedication, you'll automatically be put on there to play. What are we going to do in 2012? We are, of course, going to continue hardware upgrades on TQ. We're going to continue capacity expansions, performance improvements, and of course there's Dust 514. Enough said. And now over to James.
All right, the fun stuff begins now. So you can already see that we've put a huge amount of effort into just keeping Eve alive and up to speed and making sure that it's becoming a bit of a monster that's quite complex to operate, and it's pretty safe to say that it's going to get no less complex once we introduce Dust. Quite a few interesting challenges come when we start trying to deal with, essentially running Dust as a part of the same environment. So the first thing is we're expecting maybe 10 times as many users at the same time in Dust. As you all know by now, Dust is going to be free to play, which means that anyone in the world will pretty much just be able to pick it up if they want to, which could mean a lot more people on the servers. Every Dust user is going to be connecting directly to the Eve server. The games are inherently linked, and it's not just a case where you've kind of got the Dust server and the Eve server. The games are actually on the same infrastructure completely. So the Dust users, the Dust system, will be very much an integral part of Eve. And so part of that is we have to make sure that the two games don't impact each other too much. Even though they're running on the same systems, we need to make sure that we can segment and monitor and just make sure that if there's heavy load or issues within Dust, that it's not impacting users within Eve and vice versa. It's very important to us that we make sure that the quality of service remains at all times in both games. Next. Yes. So before Dust, this is one of the slides from a little bit earlier. We're starting to grow the Eve application. There's lots of things now, the API, image services, EveGate. And at a very simple level, we just kind of add Dust on the side. There are services within Eve that Dust will use and share. And we add battle servers, which will run the actual simulation in the Dust managers, the Dust battles, which the client will also connect to. But that's a simple version. It gets a little bit more complex when you look inside the cluster. And the Dust services within Eve, within the actual Eve application, will have their own services within the Eve cluster, which means the stuff that's primarily Dust won't really touch any of the Eve systems, which means with this kind of architecture where the system gets broken down into little blocks, it means we can put each one of these on different sets of servers, and we can scale everything as necessary within the overall system. This means that if, essentially the red boxes are stuff that's applying to Dust here. If one of those becomes overloaded, or there's any kind of stability or issues with those systems, it's not going to really impact the stuff that's running on the Eve server, because they'll be running on different sets of hardware with different requirements and things. There's an even less simple version, which is this is my architecture diagram of death. It's something that's I've been kind of working on for quite some time, but this is actually the diagram of how everything connects to make Dust happen. As you can see, there's a lot of bits and pieces. Broken largely into the kind of the red section is what is web systems. So this is like API, forums, login services, account management, all kinds of stuff like that. The orange box is stuff that's going to live within the Eve game cluster, which is also the back end and kind of persistence and storage area for Dust. And then moving on out to any number of sets of battle servers all around the world. So we have to make sure that we have command and control traffic going to and from them, that clients are able to connect everywhere. Each one of these components we have to, as a part of the process of releasing Dust, we have to performance test, scale test, make sure that we understand how each single part of this system works, understand what happens to the whole system when one of these things breaks, because they do break from time to time. So, truly global cluster. As you're all well aware, Eve lives in London. We have one server for Eve for the world, and we have to keep our promise of making sure that we stay single-sharded, stay as one world. And because Dust is a part of that, we have to make sure that we can introduce Dust services around the world to players all over the globe and still have them exist within the same virtual world of Eve. So obviously, being a first-person shooter, it's going to be a little bit difficult to play with a reasonable response time with, if you're in, for instance, the USA, with a server in London. If anyone's played any of these kind of Counter-Strike or Battlefield before, you'll know that playing on a high-ping server is pretty terrible. So we're going to be introducing battle clusters at kind of key locations all around the world to make sure that Dust users will all have an acceptable response time when they're playing the game. And these remote sites will all connect back to the central cluster of Eve. And the Dust clients will maintain connections to their local battle servers for stuff that's very latency and ping sensitive, and a connection also to the Eve cluster for less kind of latency sensitive information. So stuff like, marker names of modules, names of characters, that kind of stuff can still, you don't mind if you're waiting a little bit longer for that to load. What we've done to make this graph is we've basically worked out what the optimal response time is to play Dust. And this is information that we've just taken straight from the game designers. We're saying, what's the kind of the ping that you want to be able to play Dust really well? So mapping this out over the world, you can see that we're covering, I think it's about 80 or 90% of our users within just 3 locations for battle servers that will allow everyone to play with a really, really good response time. And then if you expand that more to what would be deemed as acceptable response time, it's still very playable, but you'll start to feel a little bit of the effects of latency. These clusters can serve pretty much the entire world. Now, one of the key things to note as well is that as we move forward, we can add and remove sites to the system at the drop of a hat. It's really, really easy with the architecture that we've developed for Dust to just simply add new locations if we need to. So if we find that there are users somewhere in the world that are getting poor experience, we can just stand up a new cluster of battle servers right near them and they will be A-OK. So fitting the pieces of the puzzle together. Dust currently is live globally. We've actually got service running in locations all around the world where we're in the final stages of getting the beta testing platform ready and all tested. So as you probably heard in the Dust keynote, in the coming months we're going to start to be expanding that. Tremendous amount of flexibility to add and remove sites as we go. And this allows us to adapt and learn very quickly as people play Dust. Of course, this is a game. No one's ever played it before. We don't know fully what's going to happen when users get their hands, how they will use it, where some of these issues might occur. So we'll just simply adapt and learn, and we've developed a system that and a way of operating Dust that will allow us to adapt very quickly. In the early stages, we're aiming to be extremely flexible, which means that as in the beta when players report issues or things that perhaps we haven't thought of, we'll be able to adjust to that. So that's kind of where we're at with Dust, and it's a pretty daunting task, I think, to add it all into the overall Eve infrastructure. But when we've broken it down, it's very manageable, and we're very optimistic and quite positive about the timelines involved and our ability to get the servers up and running to make all those awesome orbital strikes a thing of reality. So that's the end of my section. Yeah, I'll hand it back to Ingvar.
Yeah. We'll be holding a roundtable at 1 o'clock. It's called Expanding the Eve Universe. There it's basically Hardware Porn Part 2. There you'll get a chance to ask some of the system admins and us some additional questions if you have them. We're a little bit over time, but I think we have space for a couple of questions if you have or you want to ask.
I think we have a microphone somewhere. Someone has a microphone for questions.
Did you have the mic on the side? Ole, could you?
Everyone reach out and wake up your partner. It's almost over.
Ole or sysadmin will have the mic.
Hi. Your FCP, is it, that kind of redirects traffic to optimal paths? Does that use routing table updates on the internet to change routing routes back?
It uses BGP. So it does BGP updates because we have our own AS number and our own IP allocation. So it just, the way that it redirects, it sets local preference for the routes that we receive from our peers.
Okay, but it won't change, like give different information to your peers for routing back to you?
No. I don't think it has that capability.
All right, thanks.
Currently Eve is single-threaded, from what I understand. That's why you have to use the 4.4s if the gigahertz. When it goes multi-threaded, as Veritas was talking about yesterday, do you guys think you're going to move to like the AMD 48-core boxes? You can get the 4 CPU, 12-core machines, or something along those lines? Or?
So if I understand correctly, you're asking if we're going to use multi-core machines and if Eve is going to change from being a multi-threaded application in the near future?
Veritas mentioned that they were working on moving to multi-threaded rather than single-threaded. And how do you think that'll change your guys' job associated with that?
If Eve goes multi-threaded, or some part of the Eve application, currently a very small part of the Eve application is multi-threaded, and I know there's development efforts ongoing to change that. I was in one of the sessions here earlier this week. If it does, we would certainly move to multi-core machines to make use of that. Actually, the current 4.4 gigahertz Everest is a 4-core machine. It's a dual quad-core. Only 2 cores are disabled on each of the CPUs. So if and when Eve goes multi-threaded, it will be able to make use of all cores on the 4.4 gigahertz machine.
Cool.
And also we have been tackling this problem with the servers going multi-core and lower CPU. What the Eve software group has been doing is dividing the services down to more nodes. So a solar system used to be like the chat system, the character system, the solar system, and all services within that system. Now they're breaking it out, the chat system, and it's running on a separate service.
Yeah, when it's fan local,
breaks up.
Kill the node.
So we have been tackling the multi-core in that way for the past years, but we are still, the solar system, the fleet fight, that's still on a single node. And that needs to go multi-threaded, yes. So, but yes, they are working on it.
Okay, terrific. Thanks.
Absolutely. I think we have space for a couple more.
Yeah, there are at least 2 here.
Yeah, I just wanted to voice a silly concern. Your military-grade calculators seem to think that 20% of 120,000 is 20,000, and that's incorrect.
Yeah.
Just wanted to point that out. That was all.
Thank you.
That explains a few things.
I need to go beat somebody over the head after this.
So,
it wasn't me.
You're currently using SQL Server for the database, and I assume it runs on Windows machine. I hope you have valid reasons to use Windows on server, because it looked like very strange to me. Can you give an insight what specifically this setup provides better than other options for running servers?
Okay, this was a decision that was made way back when. The decision to go with SQL Server for the backend. I think way back when it had more to do with the familiarity of the developers and the system admins working at CCP at the time with SQL Server over any other product, and also probably had something to do with the pricing, because, for example, Oracle, as you may know, is considerably more expensive, and back in the day CCP didn't have a lot of money to slosh around. But since then we've added so much, I would say, infrastructure and customization that depends on this being a SQL Server, that it would be a really hard change to move to Oracle from SQL Server as it is currently. It's not out of the question, but it would require some surgery.
And I think, to speak to that as well, the real direction that things are going, you see with models like the applications like Facebook and Zynga Gaming and things like that have, if we were to look at making fundamental changes to our database and storage layer like that, in all likelihood, the effort would probably be put in the direction of going away from, or partially away from, a single kind of database environment altogether, looking much more at kind of storage cloud and caching and like no SQL options where it allows you to distribute your storage much better, and you're removing a lot of business logic from that layer. So I think, if anything, rather than kind of shifting vendors in the same overall architectural design, I think with the effort that would take, we'd probably gain a lot more by changing design slightly.
Absolutely, because a single database can't scale infinitely. It simply is not practical.
And that's something that's being looked at and in the early stages of being played with at the moment. I mean, a lot of the senior developers that we have in place now are very familiar with these new models and how we can adapt our systems in the future and new things that we're developing to make use of them. Because single database it doesn't really matter which brand it is. A single database won't simply just scale forever. And as we start to run into more and more scaling issues on that massive area, we'll start to shift more and more things out of that model.
There is also it started out as the SQL Server 2000, but throughout the years with SQL Server 2005 coming out, there were a lot of improvements, and now with 2008 and 2008 R2, Microsoft has gained quite considerably in getting closer to like Oracle. So they're starting to become now competitors. And with 2012 coming out now, it looks promising. We've set up a test system with 2012, which we are just currently working out to see how it goes. Whether we will go to 2012 is undecided yet, but yes, but this is being worked on constantly on how to improve, how to change, and what to change. And this is just done through testing and researching.
All right. I don't think we can take any more questions. We're bumping into the next session. So I'd like to thank all of you for coming, despite the early hour and the tremendous hangovers you must be having. This is a tough first session of the day, but thanks for your attention, thanks for your time, and if you want to delve more into details, please attend the roundtable at 1 o'clock in room 3. Thank you.
Thanks, guys.